Hi, I'm Jeff Jordan, Power Grid Product Manager at Copperweld. The test method we used throughout the multi-year test program replicated the original tests in the 1970s. That meant testing copper-clad steel, CCS, in air, and comparing apples to apples against copper in air. But the vast majority of substation grounding conductor applications are in the buried ground grid, or subgrade, as they say. Toward the end of the test program, after optimizing CCS for short circuit performance, flexibility, corrosion resistance, and strength, we decided to take one more leap into the unknown. We wanted to verify that ArcAngel performs just as well in subgrade applications as it does in air.
So we built the Sandbox with sand, and we'll be able to measure the moisture and hang the bus into the trough and then fill it back in with sand so that the conductor is buried and positioned and cannot move during the half a second of the test event, with the purpose of hopefully discovering if there's any effect from the motion. The theory on the street is that this will actually give us a little bit of extra ampacity in the short circuit event, because the motions we think are causing the conductor to fail early at the lugs. We'll see.
What we found is that both copper and ArcAngel conductors carry a little bit more current in buried applications than they do in air.
Here you can see our test was about 50 milliseconds longer than the past. You can see here failure at 582.6 milliseconds, where in the past we were at 540, a symmetrical shape to the curve. And what that means is that, in fact, the apparatus was causing our failure in the past, and that the new real-world example of a test buried in the earth gives us the sort of performance we're expecting, which is better than we've been seeing with open-air testing. So let's see what we got. We're gonna take the boards off here, scoop out the dirt, and take a look and see what formed as a result of this test. Now that is interesting. Can you get that on camera? Okay, so what you're looking at here is that the cable actually burned out. Now we gotta find out if it burned out at the lug or in the dead center. If we happen to burn out dead center, then we finally got the failure mode of the wire. Okay, so here we have a piece of Copperweld experimental wire that was supposed to be the same as copper 4/0, and in fact we found that when we buried it, we got the same performance roughly that we saw in the copper, which is that when it's buried, we did see a 5 to 7% improvement in the short circuit I²T value. And that seems to be because when it's buried, there's less motion in the test apparatus. How cool is that? That is some seriously good science right there. Yeah. Of all the fragments we found, I don't know what to call them except maybe fragments, but this guy here is the most interesting, maybe the most telling, because it is clearly a bit of the copper cable still intact, with a lot of the ejected copper fused into the surrounding sand, making this sort of strange copper sandstone.
So the overall test program in air holds up in subgrade applications too. In other words, testing in air is the conservative worst-case scenario. But the Sandbox test may represent the best simulation of how ArcAngel actually performs in a substation ground grid during a high-power short-circuit event.